Okay, so this section we were learning about exact equations, and I told you that we would kind of motivate it, spend a lot of time learning the steps and practicing examples, and that we would learn how to make an equation exact. And that all of this would involve a lot of algebra and integration. So we started with that motivation where we looked at a type of differential equation that you know how to solve in a different way, and then we sort of wrote it in this special way that sets us up for thinking about why we might solve something in this differential form right here. And then we talked about what an exact equation is going to look like and that special condition that you need to check in order to make sure that you have an exact equation. And we kind of tried to build intuition for that property by saying that it's related to mixed derivatives from Calc 3. And then we gave these steps for solving exact equations. This step right here we filled in later. But it was a lot to take in at once, so we jumped right into examples. And our first example was an exact equation, and we were able to sort of work through all the steps and find a general solution. And then since there was an unknown constant, we were able to solve for that constant in our initial value problem. And then I just sort of gave a word of warning that there's a lot to keep track of, so you just need to be careful and write everything down, and to remember that you need an unknown constant at the end, which you get when you do that f equal to c thing. And I know I've said that so many times, but it's just because that's the one thing that people forget on exams. So then we moved to this other example that was kind of grounded in a physical problem of a chain falling off a table. And the problem was that it wasn't exact. So we went ahead and we said there's a special formula that you can use to find something that when you multiply it by your whole differential equation, it becomes exact. And we did that for this particular problem, plugged it all in, and we obtained a solution to the problem we were looking at. And then after that, we sort of talked about why that factor actually worked, sort of going backwards and showing that if a factor did make something exact, then it would follow that formula that we used. And then since there was a little bit of time left, I went and I talked about some things that I had said that I wanted to make sure were in a single place so that you wouldn't miss them. And so I said that making sure things are exact and in the proper form is important. Do that early so you don't have to repeat your entire problem. I said that there's a lot to keep track of in these problems, and it's not good to do it all in one line. So just write out all the steps the same way I do. F equals stuff, G equals stuff, so G prime equals stuff, and I integrate to find stuff, so on and so forth. And then going back to this one unknown constant thing. So remember, the unknown constants are for an initial value problem, where we get y of 0 equal to like 3. So if you have more than one unknown constant, but you're only given one initial value, then you won't be able to get rid of all your constants. So just make sure that you combine them if they arise from your indefinite integrals. So right here, I wrote on the wrap-up screen kind of what I think we went over. So we showed how exact equations are related to differential equations by looking at a differential equation and then putting it in the same form as an exact equation. Talked about the steps to solve, which involve a lot of integration. So we looked at some examples, and hopefully that helped make things a bit more concrete. And then we talked about how to make an equation exact when it isn't already. And we emphasized how it's important to be careful with a lot of little details in this section, because the process itself is kind of formulaic as long as you don't lose track of anything. So your practice problem, the thing that you should have prepared at the start of class, is going to be to carefully solve this exact equation, y dx plus x dy equal to 0. And what I'm going to say is that it is, I know, exactly the same thing as I motivated this section with. But probably when we went through the video at first, sort of that right-hand side where I made it look like an exact equation and then solved it wasn't very satisfying. And I did it in kind of a sloppy way. So what I'd like you to do is work through it the same way we did our two examples, where you really carefully show that it's exact and then find F and G and make sure that you know what the solution is. And you can check against what I said the solution is, or the solution that you could find as an separable equation if you wanted to. So just find the general solution to that differential equation and we'll talk about it in class.